about that. Okay, let's do some examples about the square root method, and then we're going to take advantage of that idea to actually be able to solve the quadratic equation completely. And we're going to do that by the method of completing the square. The reason why I say completely is because, there are equations that what we just discussed we cannot solve, because we were relying on the fact that we could factor a polynomial. If I give you something like x squared plus x plus 1, this is something that we cannot factor, but still we would like to solve this, okay? So factoring is not bulletproof. I mean, there are problems that you cannot solve by factoring, like this one. And the square root method is also not bulletproof. You cannot solve this using the square root method, okay? So how do we deal with this type of situations? That's what completing the square is going to do for us. This will allow us to solve quadratic equations completely. And what we're going to do is we're going to see that it's a slightly longer process. So we're going to do it one more time in general, and we will obtain a formula from it, which is what we call the quadratic formula. It's typically what we use, okay? But you need to understand the quadratic formula is really just completing the square. It comes in a package, and you plug in numbers and you get a solution, but you need to know why that works. Okay, so we'll do that now. But first, let's talk about the square root method. So let me write it here. The square root method is exactly what I mentioned earlier, and it says if u squared equals to b. Okay. So let me say let u be an expression and be a real number. Now, it doesn't have to be positive, okay? It could be negative, as you saw in the previous example. Let u be an expression and be a real number. Then the equation u squared equals b has the following two solutions, or has solution. So what's the solution of this equation? How can we write it? U equals
plus or minus b.
Plus or minus
The
square root b. Okay? Now, the reason why I'm writing this with u instead of x is because this u could be an expression containing x. Okay? So this doesn't have to be x squared equals something. You may have something involving x equals a number. As long as that something is being raised to the square, you can still take advantage of this property. Okay? And you're gonna see that in the examples. But let's see. Let's do some examples. So solve. Let's do the square minus 20 equals to 0. Okay, this one we already did it. So let's do this one. Let's do this one. Okay, so the moral of the story is that if you want to use the square root method, what you need to do, you have to make sure that you rearrange your equation in such a way that on one side of the equation you have a quantity squared, and on the other side you have a number. Okay? Once you manage to do this, then you take square roots. And remember the plus or minus. So, for example, you have to do slight work in each of these before you can directly apply the square root method. Now, a quick hint of when the square root method is useful is in situations like this, when you have a quadratic equation and the middle term, the one with the x, is not there. Okay, so when your b equals 0, if you think about ax squared plus bx plus c, do you understand what I'm talking about? In other words, the square root method is helpful for equations of the form ax squared plus c equals 0. So if the bx term is not there, then you just move the c over, divide by a, and take square root. Okay. If you have a middle term with an x, then you have to either try factoring or the other techniques that we will soon discuss. Okay, so how about the first one? What do we need to do? What's the first step? So we move the negative 20 to the other side. So we get x squared equals 20. Yes? All right. And what do we do? So just square root. plus or minus. It's very easy to forget the plus or minus. Okay? It's your responsibility to write plus or minus. Do you understand this? So there are two solutions here. Positive square root of 20, but also negative square root of 20. Questions? Okay, so now, you always have to simplify as much as you can. Can we simplify square root of 20? Yeah. How do we simplify this? So 20 is 4 times 5, yes? And the 4 we can take it out as a 2, because square root of 4 is 2. So we get here plus or minus 2 square root of 5. So understand that there are two solutions here. One with a positive, let me emphasize that. There's one with the positive, and then one with the negative. Okay? Typically, we just give it like this and write plus or minus 2 square root of 5, but you need to understand that there are two statements here. Okay? All right. Questions? Okay? Okay, perfect. How about the next one? What do we do? Yes?
First you move the 5 over.
Okay, very good. So we move the 5 over because, again, the idea is that we already have something here squared, right? And remember, you can think of that as your u in the definition that we have here. So we just have to make sure that we have this guy by itself, and then the rest of the stuff we move it to the other side. Good. And then, so we subtract 5, what do we get? 16. And then
square root of 16 and take it off the x minus 2.
We use the square root method. So what do I write in my next line?
X minus 2 equals 4.
Are you sure?
4 like the square root of the 16 squared.
Are you sure? Plus or minus?
Plus minus.
I don't know how many times I've said this. I'm gonna say it again. It's very easy to forget, and then you're gonna lose one solution. Okay? Remember, when you use square root method, you need to do plus or minus square root of whatever number you have on the other side. Okay? So now, there are two little equations here. What are they?
X equals,
so let's write the equation. So x minus 2 equals positive 4, right?
X
Minus 2 equals
negative 4.
-4. Does everybody see this? Those are the two equations, one with the plus, one with the minus. Now finish solving. So we get 6 or -2. Questions? Okay, good. About number 3. Any ideas? Yes?
Use the formula, the quadratic formula.
Well, we haven't discussed the quadratic formula. So the idea here is to do it using the square root method. Yes?
You can factor the left side to be x plus 2 squared.
Very good. So in other words, even if it doesn't appear that you may be able to use square root method, you can actually may be able to do some modifications so that you can use it. In other words, we cannot hope to get something like this because, there is a 4x in here. But then, can we get something like this? Okay? So we write the left side as something squared. And then we can use square root method. And it turns out that in this particular case, we can, right? So we can write this as x plus 2 squared. Does everybody understand this? So x plus 2 times x plus 2 equals 10. Okay, good. And now at this point, this problem is very similar to the one that we just did, right? The square root and so on. Hey, I'm not using quadratic formula because technically we don't know the quadratic formula yet. So we are building our way towards the quadratic formula. Okay, so from here we get x plus 2 equals plus or minus square root of 10. Okay? And now, because this doesn't simplify nicely as an integer, then instead of splitting this as two equations, because here I did it because we're going to get two nice numbers in solution. Typically, we just keep it as a package together. and just move the 2 to the other side. And then, you can report your answer as -2 plus or minus square root of 10. And that's fine. You need to understand that there are two numbers here. What are the two numbers? -2 plus square root of 10. And what's the other number?
-2 minus.
-2 minus square root of 10. But, most of the time we report the answer like this. But it's understood that people know what we're talking about. In other words, if you were going to write the solution set, then you say -2 plus square root of 10, and the other one is -2 minus square root of 10. Okay? All right. Questions? Do you understand when to use the square root method? Yes? Okay. Now, of course, we cannot always do that, okay? For example, what if this 4 was not here? What if we had a problem like this, but without this plus 4, we only have x squared plus 4x equals 10? How do we do something like that? Okay? Because this wouldn't factor nicely the way it did now. You could try bringing the 10 over, but then you have a -10. You're not going to be able to factor it in. So two numbers, product is -10, and the sum is close to 4. You're not going to find it. Okay? How do we do this? So something else needs to be done. So let me, and basically the idea is that how do we do it? Well, we put what we need so we can do this process. We need a 4, we put it. So really the question is, how do you figure out what you need to put so that then you can do this process? Okay? So that's called completing the square. So you may have something that's not exactly a perfect square, but we complete it. So we add up whatever we need to make it a perfect square. And then you activate this process. Once we learn this technique, we're going to do it one more time in general, and that was give rise to the quadratic formula. Okay? So, but let's do that. So what we're about to discuss is the process of completing the square. So let me say, note, remark. The above techniques are not enough. And so far we've discussed two, factoring and square root method, and not enough to solve quadratic equations. Right now we're just focusing on quadratic equations, okay? Since equations like, let's say, x squared plus x plus 1 equals 0 cannot be solved this way. Okay, so we need something more. So let's discuss that. What do we need? Okay, so the method that works all the time is what we call completing the square. So completing the square, and like the name suggests, we're gonna try to complete the square, to take something that's not a perfect square and make it a perfect square. Okay? So let us do some examples, and hopefully we're going to spot some sort of pattern. Okay? So factor, and let's do x squared plus 6x plus 9. Let's do, let's see, let's do them like this. Let's do x squared plus 10x plus 25. And then over here, let's do one space. Okay, so here we have 4 polynomials. Let's factor them. Okay, and again, there's a reason for this, of course. We are after some type of pattern. Okay, so how do we factor the first one? Yes?
Factors of 9 that add to 6, which should be 3 and 3. And that gets you, that's a square.
So we get x plus 3 squared, right? Okay, how about the second one?
X plus 5 squared.
X plus 5 squared. So two numbers whose product is 25 and the sum is 10, so that's 5 and 5. So x plus 5 squared. Good. So how about the third one?
X minus 3 squared.
What is it?
Minus 3 squared.
X minus 3 squared. Does everybody see this? Two numbers whose product is 9, but this time the sum must be negative 6. So you need the two numbers to be negative, right? So negative 3 and negative 3. And the last one?
X minus 5 squared.
X minus 5 squared. Okay, good. So let's take a look at this for a second. One thing is that all of these were perfect squares, right? So question, how can we spot whether a given polynomial is going to be a perfect square or not, a quadratic polynomial like this? Notice that in all of these examples, the leading coefficient is 1, okay? And we're just going to discuss this because when it's not 1, then we can make it 1 because we're solving an equation anyways. So we're not going to worry about having a number here because that, we made the formulas more complicated. There's no reason for that. We can simplify it always to make it nice. Okay, so we have a 1 here. So whenever you have a polynomial like this, what do you see? So all of these guys are perfect squares. So is there some type of pattern or something that you can realize? Yes.
The last term is 3 squared.
Okay, but for example, if I write this, the last term is a perfect square, right? Now, is this a perfect square? No, right? So that's a good thing. So first of all, if you want a candidate to be a perfect square, we better have the first to be an x square and the last one better be a perfect square. That's a good thing to look at. But that's not everything that you need to consider. What else must be satisfied? And it has to involve, of course, something about this middle guy. Yes?
Term b has to equal the square root of the last term times 2.
Okay, does everybody see this? So let's see. What your classmate is saying is, okay, if you take the last term, which is a perfect square, you square root it, and you multiply it by 2, you should get the middle term. Let's see if that's true. Square root of 9 is 3 times 2, 6. That's exactly what we have here. Yes? Square root of 25, 5 times 2 is 10. Square root of 9, 3. Okay, so let's review that a little bit more.
Well,
3 times 2 is 6, it's not negative 6. So we should look at whatever number we have in here and not in the positive or the negative. Yes?
Yeah.
Okay. We're going to rephrase this a little bit more that we take into account everything. And then again, in not in the negative, we have this guy squared. The square root of this guy is 5 times 2 is 10, but then we have a negative, but we're ignoring it for now. Yes? Now, the thing is that you told me that thinking about already knowing this, which is fine, but if you already know this, you also have all the ways of factoring, right? Just find the numbers and so on. The question is, what if you didn't know this? Because really, for example, like in this problem, we know that this one doesn't work. Okay, in order for, what do I need to have here so to make it work? So what I want to do is backwards. If you know your B, which is this middle guy, how can you figure out the C that you need to make it a perfect square? So what you just said, let's do it backwards. Okay, so what your classmate said was that the square root of C, so let's see. Okay, C is a perfect square, so we can write C as K squared. So that means that we square root that and then multiply it times 2, and that should give us our B. That's what you said, right? Now, this works if B is positive, but if B is negative, remember because you start with this number, when you square root, then you will get two possibilities, the positive and the negative. Because what you really want is something whose square is C. So you need to consider both of those guys, positive or negative. So it will be a plus or minus here. Okay. So it will be a plus or minus here, and then you can just say that B is going to be plus or minus 2K. where k stands for the positive square root of c. Okay, but this k, so let's see, this k we can obtain it by doing plus or minus b over 2. So this right here is a secret. So again, the plus or minus is already taken care of by the equation itself, so that's why I was saying you don't even need to worry about that. But right here we have the little formula. So if you want to figure out what number to put in here, what do you need to do? Take the middle guy, divide it by 2, that will give you the k, but then the number that goes here is the square of k, right? So you square it. In other words, one number should be in here instead of 4. Take this guy, divide it by 2, and square it. What do you get?
1.
A 1. So instead of a 4, we should have a 1 in here. Do you understand this? Now with the 1, then you could factor this as x plus 1 squared. This is called completing the square, okay? So to complete the square, what do you do? Take the middle coefficient, divide it by 2, and square it. And that's what you need to have. If you don't have it, then you make it appear. Yes?
We can just go to the vote for who.
Yeah.
Yeah. Thank you.
Yeah. Did you understand this? Okay, so let me write it down. So I guess, okay, I'm gonna keep this analysis here. Let me just say that this plus or minus, this is already in the equation. Or if you want, it's already part of B. Because when we talk about B, for example, here was B in this formula. What is B? B is -6. B is not 6. Okay? B is -6. So this plus or minus is really already encoded in B. So already part, I would say, of the equation. And then to be technical, I should do this. Okay. No. It's just that the B that I'm writing here is not the usual B. So, but I want to somehow specify why we needed the plus or minus. So it's already part of the equation, and I'll say here. Yeah, okay, no, this is fine, because then B itself could be positive or could be negative. So B has to be this, the plus or minus. Okay, that's good. So all of this was side calculation, the side discussion. Let me just summarize this. So note. So if you want to complete the square, the point is that you should focus on this guy, okay? So in part A, notice that if we take the number 6, and if we divide it by 2 and we square it, then we get 9, which happens to be the last guy, okay? Similarly, if we take 10 and then divide it by 2 and we square it, we get 25, which is the last guy. And then, the observation is that whether you take a positive or a negative, it doesn't matter. You divide it by 2 and you square it, you keep getting what you're supposed to get, okay? So take the -10, divide it by 2 and square it. You keep getting what you're supposed to get. Now I'm leaving a little space here because I want to do the actual in-between calculation. Notice that the in-between calculation is 3 squared. Here we get -3 squared. Here we get 5 squared, and here we get -5 squared. And why am I saying this? Because now we see also another little pattern. You not only, this is the process of finding the number that you need to complete the square, divide by 2 and square it, but also here you already know how immediately it's going to factor. So I want you to pay attention to this. When you factor, the number that you put here, it's exactly this guy. So b divided by 2, okay? the number that you put here is this one. The number that you put here, including the minus, is this one. And this one. In other words, when you factor, b divided by 2 is what goes in here. It's important because typically the numbers are not going to be nice like this. There will be fractions involved. And then factoring a polynomial with fraction may be a little bit of pain. Okay? So, for example, I guess let's do x squared plus x plus 1. Or let's do x squared plus x. And then let's do this example. Tell me what should be here so that this becomes a perfect square. What should go in the blank. So according to our discussion, what's the process? Look at the coefficient, right? At your b, and then what do we do to it? Divided by 2. What's in red? That's the common part, right? What I draw in red. Divide by 2 and square. Yes? So to figure out what goes in the blank, what you do is, okay, here is my b, then I divide it by 2 and I square it. All right, so what is this?
1/4.
1/4. So this is what we need to have here, a 1/4. Okay. Now, how does this factor? We need to factor this because we're doing this so we can factor and solve the equation. So you can think about how to factor on your own, but when you start having fractions, then it could get a little bit tedious. But I already told you about it. B divided by 2 is exactly what goes in there. Because it is a plus, then there's going to be x plus something squared. What is that something? B divided by 2, which is 1/2. Did you understand this? Okay, so let's do a couple of examples like this. So what we just did here is what we call completing the square. So this process is called completing the square. Okay, and I guess the method is, so to complete the square in the expression, and the expression will be x squared plus bx, okay, plus blank. What we do is we take, so we find or we add the quantity. The quantity is, look at the number b divided by 2 and squared. In other words, b over 2 squared. Now, I want you to understand that if this was a minus, it's also the same thing. Okay, remember, if this is a minus, the plus and the minus is already part of b. Okay, so in general, we write like this. If it is a negative, it's because b itself was negative. Okay, all right, and this will always factor as. How does this factor?
X plus b over 2 squared.
Good. Okay, and it factors as x plus b over 2 squared. And once again, if b was negative, then it would be a negative, right? If b is positive, then you have a 2 positive. Okay, so that's what completing the square is. So this way, actually now we can solve any quadratic equation. So let's practice completing the square, and then let's use it to solve equations. So example, complete the square. And then factor. Remember, the factor part really is once you complete the square, it's already a given. You already know what to expect. Okay. All right. So let's do x squared plus 16x plus blank. Let's do x squared plus 5x plus blank. Do you understand the question? I'm asking you, tell me what number should go in that little blank. So what we obtain is a perfect square. Okay? So the polynomial factors as something squared. That's what we want. Remember, to say that we're completing the square is to say that we want to write this like this. Okay? We want to write this like this. We just need to figure out what should go in the little line. Okay. All right, the first one. What do we need to have in there? Very good. The 64. Everybody understand where the 64 is coming from? So just take the 16, divide it by 2, and square it. That will give you 8 squared, which is 64. Okay, that's the number that we need there. Now, how do we factor? X plus 8 squared. Very good. Questions? Okay, the next one. What do we need to have in the blank? 25 over 4. Good. Does everybody understand where the 25 over 4 is coming from? Just follow the formula. So you take your 5, which is our b here, and then divide by 2 and square it. Right? It's just that here it doesn't 5 divided by 2 doesn't simplify nicely like in the previous cases. It doesn't simplify, so that's fine. Nothing wrong with that. Then when you square it, you get 25 over 4. So that's what we need to have in there. Now, this point is really helpful. The little tip that once you do this, we already know how it's going to factor. Okay? Instead of worrying about how to factor this, you already know. So what is it? X plus 5 over 2 squared. Good. All right. Questions? You okay with this? All right. So now let's. This is called complete the square. We're gonna, as an application, we're gonna use it now to solve equations. Later, when we talk about quadratic functions, we're gonna use this to write a quadratic function in what we call the vertex form. So then it's very easy to graph it and so on. Okay. So complete the square is used in different scenarios. It will also be used when we talk about circles. How to take the general equation of a circle. And then if you want to know what's the center, what's the radius, what you do is complete the square, and then it's pretty easy to find the information. Okay? So, this is a general technique. Now, as an application, in other words, this is not just to solve equations. That's what I want to say. Okay? As an application, we can use it to solve quadratic equations, solving quadratic equations. Okay, so for example, let's do x squared plus x plus 1 equals 0, the one that I was talking about at the very beginning. That, that was something that we cannot do by either factoring or square root. Let's try that one. Then let's do, let me put all the ones. Then let's do x squared plus 4x minus 7 equals 0. Let's do x squared minus 5x plus 2 equals 10. And then let's do 2x squared plus 12x minus 9 equals 0.
If I have to leave early, can I just leave early? Because my dad has to pick me up at 11.
If that happens, then you make sure that you email me letting me know what happened. Right? So that's fine. Okay, so here we have 4 equations. Let's solve them. Okay? Remember, we don't know quadratic formula yet. So you should, again, when you are faced with a quadratic equation, my advice to you is first try to see if you can factor this. If you can, that's quick. Okay, you can do it very quickly. Now, if you cannot, maybe you can use square root method. Otherwise, then that's when you rely on this what we're about to do now. Of course, you're gonna see that what we're gonna do is slightly longer. So that's why we actually develop a formula, and then if you cannot factor or use square root method, then you jump straight to the quadratic formula. Okay? But that will be after we discuss the formula. All right, so let's see. Let's do them together just to save time. Or at least, I want to do the first one, then I'm gonna let you try the other, 2 and 3. Okay, so we wanna solve x squared plus x plus 1 equals to 0. Is everybody convinced that we cannot factor this? Yes? Okay, so we cannot factor this, and also square root method cannot be used directly. Why? What tells you cannot use square root method directly here? Because of this guy, right? It's an x in here. If we didn't have this x, then we can just move the 1 over and then take square roots, right? Now we have the x, so what do we do? Okay, let's complete the square. So the point is, or the observation that we make, first of all, this process of completing the square works when we have a 1 here, okay? So for example, in problem 4, we need to do something before we activate what we're about to discuss. But we'll talk about it when we get there. So what we want to say is, okay, the problem is that I want to have a perfect square, it's just that this guy is not what it's supposed to be, right? So this number should not be a 1, should be something else. You can always complete the square, it's just that you need to have the correct number in here. So what we do is, okay, this guy doesn't belong here, so let's push it to the other side. So you push it to the other side. I'm going to leave a space, right? And then we turn this into an exercise like the one that we're doing before. Let's complete the square. So figure out what should be here so that this, the left-hand side becomes a perfect square. So what should I have in there? 1/4. Does everybody understand this? So we need a 1/4. So what do? Well, we put it. And now, you need to understand this is an equation, right? You cannot just put stuff however you want. So if I add 1/4 here, what also do I need to do? You need to add it on the other side. In other words, you need to make sure that you keep the same equation. The solution, we don't want to change it. So if I add a 1/4 over here, I need to add it on the other side as well. Does that make sense? So, and now what's going to happen? This becomes a perfect square, as we know. So we know that by doing this, the left-hand side is going to look like this, and the right-hand side will be a number. And now this is like the exercise we were doing earlier. Then you take square root and you finish solving the equation. Okay? So that's completing the square. All right, so let's do it. So what's x squared plus x plus a quarter? How do we factor this? X plus 1/2 squared, and then -1 plus 1/4. Is everybody okay adding or subtracting fractions? Do I need to explain this? So I'll just say quickly. So remember, the easier way is to make sure the denominators are the same. So you can always think of this as being over 1. So to make the denominators the same, you find the LCD. Here the LCD is 4, right? So we just need to have a 4 here, and you can do it by multiplying top and bottom by 4. Okay? So you can just do times 4 times 4. And the reason for that is because when the denominators are the same, you just combine the top. Okay? So -4 plus 1, that's -3. So we have -3/4. You okay with this? Okay. And now, how do we solve the equation? The square root method, right? So x plus 1/2 equals plus or minus. I don't know if I said this like 10 times already. You have to be very careful when you use the square root method, okay? Plus or minus square root of -3/4. Okay? Now we simplify. So let's see, let's simplify this one before I continue. So that's plus or minus. So the negative will give you what? What does that negative give you inside the square root? There will be an I in the answer. So it will be a square root of 3/4i. But we can simplify that as square root of 3, then over 2 times I. So it's the square root of the top divided by square root of the bottom. And now I'm going to move the 1/2 over. So we get -1/2 plus or minus square root of 3/2i. So please understand that there are two solutions here. So what are they? What are the two solutions?
X equals -1/2 plus square root of 3/2i, and x equals -1/2 minus.
Okay. And as promised, the observation that we made earlier, if a complex number is a solution, then you for free get the other one immediately. The conjugate must be a solution. Okay. All right. Questions of this process? Now with this you can solve any quadratic equation. Okay. The only thing is that you have to make sure that there is a 1 here. So what you do if you don't have a 1 here, if you have a number, the first step would be divide the entire equation by that coefficient. So you force the 1 to show up, and then you activate the process. Okay? So with this, you can solve anything. All right, any quadratic equation. So do 2 and 3, and then we'll do 4 together. Okay, so let's see. Do you guys have solutions for number 2? What do you get?
Square. The square root of 11 minus x is equal to the square root of 11 minus 2, or x is equal to the negative square root of 11 minus 2.
Okay, so let me combine so negative 2 plus or minus square root of 11.
Yeah.
That? Okay. How about number 3? Did you manage to do it? Yes? Plus or minus square root of 17 over 2. Wait, there are 3 solutions here. So,
Oh, I'm sorry, I didn't copy down the 10 places.
so what did you get for number 3? It's just that you gave me 3 numbers.
No, I just did it wrong because I didn't put a 10 at the end.
Oh, yeah, but even that, remember, if you do a quadratic equation, you're expecting 2 solutions, at most 2 solutions. So, yes?
Plus or minus the square root of 67 divided by 4, and then plus 5/2.
Plus 5 over 2, like that?
Well, yeah, the 67 is like that.
Like that?
Yeah.
Okay. Is everybody getting the same thing? I mean, we're gonna do it now. We'll see.
I did.
67 or 57?
I got 57, and it would be over 2 since it's square root of 4.
Okay, let's see. So 57. Or some of you are saying 57 instead of 67.
Yeah.
1 over 2. So plus or minus 1 over 2, like that.
Mhm.
So then we can throw in the 5 in there.
Yes.
Make sure you do it complete the square and not using the quadratic formula. Okay. All right. Okay. Anyway, let's see. Let's do it. So let's see. Number 2. And then we're gonna see. All right. So number 2 was x squared plus 4x minus 7 equals 0. All right. So what's the first thing that we should do? Okay. Before that, see if you can factor. Right? Convince yourself that there is no easier way of doing this. Because it's not that this is difficult, it's that it requires several steps. You can factor to do this in one line. Okay? So convince yourself that this is something that you can now factor nicely. Okay? Look at it. Okay. 7 is prime, it's 4 here, there's really nothing that you can do to get to 4. So we'll try something else. Quadratic square root method is not a good idea here. So we try completing the square. So negative 7, we move it. Okay, good. So we are here. Also, you quickly look at it and make sure, verify that you have a 1 here. If you don't have a 1 here, you need to first divide by whatever you have in here. Okay? That's the first order of business. Okay, so now what do? So we complete the square. So we figured out what should be in here, right? And that is 4. Why 4? So you take this guy, divide it by 2 and square it, right? So I'll give you 4. So you add it here, but then you have to add it to the other side as well. Do you understand this? Okay. Now, what's the left hand side?
X plus 2 squared.
X plus 2 squared, and then equals 11. Okay? And now from here, we get x plus 2 plus or minus square root of 11. So x is negative 2 plus or minus square root of 11. So even though it may seem slightly longer, hopefully you should agree that, in general, this is an easy process in the sense that if you understand what's going on, you can do this anytime that you need to do it. The quadratic formula, once we talk about it, is good. It's nice because you get the answer in one shot, but there is a drawback with that formula. What is it? You have to remember. If you write the wrong formula, or if you miss something there, then that's it. You get the wrong answer. While this, if you understand, when you understand something, you don't forget. And all we're doing is adding, subtracting things. And the equation is telling you what. After you do this, then the rest is automatic, basically. Okay. So don't neglect this, because if you're not good at memorizing stuff, or if, you feel like you may forget, well, remember there are tendencies. Okay. All right. So that's good. Let's do the next one. Okay. Questions about number 2? No? Okay. Let's do the next one. The next one was x squared minus 5x plus 2 equals 10. Okay. So again, here, before you try something else, just visually, just move the 10 over. You're gonna get a -8, right, over here, and see if you can factor that. So we have -8, but then here we have a -5. No way to get to -5 with -8. Okay, you cannot split that nicely. So we try this. So we push the 2 over and give you positive 8. Okay, what do we do?
Divide 5 by 2 and then square it. -5 by 2 and square it.
That give us
Negative 20, that's 20 plus a 25 over 4.
so 25 over 4. That's what we need. So we add it to both sides. Does everybody understand this? So we add this to both sides. Now remember, this is automatic. You don't have to think about it. The left side, what does it become?
X minus 5 over 2 squared.
X minus 5 over 2 squared. That's automatic. So that's why we chose these numbers. So I didn't factor like this. So you don't have to think about it. All right. Now the right hand side, we need to combine. Is everybody comfortable with this? Just multiply top and bottom by 4. So you're gonna get 32 in here, and then you do 32 plus 25, right? That is 57. Are we okay? All right. And now square roots and so on. So we get x minus 5/2 is gonna be plus or minus the square root of 57 over 4, or plus or minus square root of 57 over 2. Let's see, 57, can we simplify that? We can divide this by 3. What's 57 divided by 3? 19. Okay, 19 and 3, none of those are perfect squares, so keep it like that. And then move the -5 over 2 over, so we get 5 over 2 plus or minus square root of 57 over 2. Okay? And if we didn't know better, we'll keep it like this. But typically when this happens, we like to report the answer in this form. Since the denominators are the same, might as well combine. Yes?
And we didn't do that for the first one because since it was a complex number in the second one, so the correct form is you keep them separate.
Yeah, a plus bi. Exactly. But here, because this is a full number, instead of giving me, because if you give me the answer, you'll tell me, oh, it's 5/2 is a number plus another number. No, come on, add it. Give me one number. Okay? That's why we make it a fraction, because it's the same. And then with the plus or minus, I'm keeping it like this because, for example, if you were to use the quadratic formula, this is what you would obtain. Right? Expression like this. So we start seeing something familiar. But understand that there are 2 solutions here, right? One with a positive, and then another one with a negative. Okay. Questions? All right. And let's do the last one, and then let's take a little break. 2x squared plus 12x minus 9 equals 0. So let's see, there's nothing that we can factor here. And then -18. Can we get to -18 with 12? Like, can we break out -18 to obtain 12? That would be 9 and 2. Not going to work. One of them negative even, so it's not going to work. And 6 and 3 is not going to work either. So forget about factoring. So I will try completing the square, but that process above makes sense if we have a 1 here. So the first thing that we need to do is get rid of this guy. How do we do that? Divide everything by 2. So just take the entire equation and divide it by whatever the coefficient is. So we get x squared plus 6x minus 9 over 2 equals 0. And now we activate the process. Okay? So bring this guy to the other side because it's not what's supposed to be, right? Then we begin. What do we need here?
Half of 6 squared.
Which is?
9.
9, right? So we need a 9. So we add 9 to both sides. Everybody okay? Do you know where the 9 is coming from? It's right here. What we're doing is, we're taking the 6 and then we're dividing it by 2 and we are squared. Remember, that's the process, okay? So that's 3 squared, which gives you 9. So the left becomes x plus 3 squared. And what's the right? What do we get on the right hand, on the right side?
27 over 2.
27 over 2. Yes. So again, what you do is multiply this top and bottom by 2. Remember, this is 9 over 1. So you get 18. 18 plus 9 is 27. Okay? Yes, 18 plus 9 is 27. So 27 over 2, and now the square roots. So plus or minus square root of 27 over 2. And then we get that x is negative 3 plus or minus. Let's see, I'm going to, and this way I take advantage to explain this. Let me simplify this. Do you know how to rationalize this? So remember, whenever you have an expression with a radical expression like this, there are two things that we don't like. First, we don't want to have fractions inside a radical. Second, if there is a fraction already and there is a radical in the denominator, we don't like that either. So if possible, we would like to eliminate this type of situation. So when you have a fraction inside a radical, okay, split it like this. So that problem is gone. But now we have a new problem. We need to get rid of this. The process of getting rid of that radical is called rationalizing the expression. So how do we do that? We multiply top and bottom by a quantity that will make sure that this radical is gone. So what can you multiply this by to get rid of the square root? Just multiply by itself, right? So multiply top and bottom by square root of 2. This process is called rationalizing. So this becomes plus or minus the square root of 54 over 2. Okay? All right, so that's what I'm going to put here. So square root of 54 over 2. And then, don't leave it like this because here you're giving me the answer as a sum of difference of two numbers. So combine, okay? So we can combine this a little bit more. Negative 3, we can write it as negative 6 over 2. And so we obtain negative 6 plus or minus square root of 50. Oh, wait.
Sure, you're right.
Wait, yeah, we can simplify this. Okay, so let me just simplify it right here. Okay, so 54 is 9 times 6, right? So the 9 comes out as 3. So we get 3 square root of 6. That's better. Well, we need to simplify here, and that way we don't have to worry with the 54, but that's okay. Okay, questions? Yes? Oh, because I want to combine this. So remember, this is over 1. So to combine them, I need to have a 2 down here in the denominator. So you multiply top and bottom by 2. And that's why we have negative 3 times 2 is negative 6.